Assalamualaikum warahmatullahi wabarakatuh. My name is Sasha Amira and my member's name is New Hui. Okay, we from section 2G and our lecturer is Sir Razali bin Muda. We from University Malaysia Pahang. Alright, so we would like to present about the laboratory, which is simulations of analog modulations, modulator and demodulator. So our topic is about the single sideband full carrier Ssbfc. Alright. Okay, this is our first slide, which is single sideband full carrier. First, in the laboratory, we have learned how to simulate analog addition modulator and demodulator by using MATLAB programming. The topic is given is Ssbfc. And second, single sideband is to maintain some degrees of compatibility with simple AM receivers and still reduce the signal bandwidth. And the third is the concept of the single sideband is very simple. The concept of the single sideband SSB is very simple. If you don't need to sideband get rid of one to make it happen, you merely add a component to your system that remove the extra sideband. The extra sideband, that component is called a band pass filter. For the next slide is indicate the process of SSD. For the graph output of ADSB as signal 1, for the signal 1 is looks like this. Then after that is graph output of the SPBC signal for the graph number 2. Then the third graph is the graph signal sideband for the third graph. You can see that the process of FSD. Alright, for the next slide is simulations GUI MATLAB application signal sideband. So we do the simulations in the GUI. So this is how it looks like. Alright, we apply the 4 types of static tags to toggle button for edit text and also 5 edits. So we rename. For the next, it shows that we rename the that we apply. First of static tags, we rename with in frequency formations, a frequency carrier, then amplitude informations, and also amplitude carrier. And then for the toggle button, we rename with which is a process and also reset. And then next is edit text. We blank it because we need to put the value for the input. Then after that, the output will come out with the output of Malaysian single sideband. We can see that the output of the SSD, right?
Hi everyone, my name is Hui and I'm here to present about the assignment simulation of digital modulation. The title is Quadrature Phase Shift Keying (Qpsk). From here we can see the first graph is the Qpsk phase shift, and this is the constellation diagram. Phase shift keying Qpsk is a digital modulation process which conveys data by modulating the phase of a constant frequency reference signal, where the modulation is accomplished by varying the sine and cosine input at a precise time. In the case of quadrature phase shift keying (Qpsk), it is a form of phase shift keying in which 2 bits are modulated at once, selecting one of 4 possible carrier phase shift, which is 45 degree, 135 degree, 225 degree, or 315 degrees. Qpsk also allows the signal to carry twice as much information as ordinary PSK using the same bandwidth. Next, the quadrature phase shift keying (Qpsk) is also a variation of binary phase shift keying (BPSK). Instead of converting the digital bits into a series of digital streams, it converts them into bit pairs, which decrease the data bit rate of half. To comparison to BPSK, Qpsk is able to transmit twice the data rate in a given bandwidth at exactly same bit error rate BER. In Qpsk, 2 bits are grounded at a time and mapped into one of the 4 possible signals. From here, this is the graph of Qpsk waveform for 2-bit input and different binary input modulate result. Okay, next, this is the Qpsk modulator and demodulator diagram. At the left hand side is the modulator, while the right hand side is the demodulator. In quadratic phase shift keying Qpsk, two synodinous, which is sine and cos, are taken as pre-required function for modulation. Modulation is achieved by varying the phase of the pre-required function depending on the message symbol. A bit splitter, 2 multiplier with local oscillator, a 2-bit series to parallel converter, and a summer circuit are used in the Qpsk modulator, while 2 product demodulator circuits is used in Qpsk demodulator with local oscillator, 2 band pass filter, 2 integrator circuit, and a 2-bit parallel to series converter. Next, from our assignment, this is the circuit of quadratic phase shift keying that we built. This is the random integral generator, and this is the Qpsk modulator. This is the AWGN channel, and this is Qpsk demodulator band. From here, the input is given is 2 sine wave, and this is complex to real image. Okay, one sine wave and complex to real image will be product it, and another sine wave will also product with the complex to real image. After we get the product, we add it up and we get the output in the scope. Okay, this is the output of the scope 1, which is the above diagram, above slide, that the scope 1 at the upper, and this is the output, and then this is the input of the sine wave, and this is the output of the Qpsk. Next, this is about the simulation guide MATLAB for Qpsk, and this is the design of Qpsk for using GUI. This is the input, and then this is the output. First, this column is for user to insert the desired input value, and it will generate the input and even bit input and odd bit input. And here is the random 10-bit binary number will generate by the GUI. After this is generated, and then it will have the output waveform. For the first output waveform, this is the even sequence of BPSK, which is the even bit input multiplied by sine 2 pi fct, and this is the odd sequence of BPSQ, and this is the input of the odd bit multiplied by cos 2 pi fct. After the result, it will produce the Qpsk waveform, which is the sine waves, the even sequence of BPSK plus the odd sequence of BPSK, and it will produce the Qpsk. Thank you.